Well, good day to you students, and we're on lesson 8.3, dividing monomials, page 387. We'll start with number 5. So here we see 10 to the 9th divided by 10 to the 3rd. Number 5, 10 to the 9th divided by 10 to the 3rd. What you do when you divide monomials is you're going to subtract to the exponent. So that's going to equal to 10 to the 9 minus 3, which is equal to 10 to the 6th power. And if we can do that, that would be a 1 with 6 zeros. That's 1, 2, 3, 4, 5, 6. That's equal to 1 million. If you want an exact value, 6. We have here 3 to the 12 divided by 3 to the 9th. 3 to the 12th divided by 3 to the 9th. That's equal to 3 to the 12 minus 9, which is equal to what? 3 to the 9th power. If you wanted to do an exact value, you would go take your calculator and go 3 raised to the 9th power, and we get 19,683. And that's that one. All right, skip down to number 8. It says use the quotient of powers property to simplify each quotient. Assume that the conditions of the property are satisfied. So number 8 says, then we have a to the c divided by a to the d. A to the c divided by a to the d. Well, we don't have any values for a, so you simply express it as a to the c minus d. And whatever your exponents will give you a value. What about d to the 12th divided by d? Number 9, d to the 12th divided by d. Well, that's d is equal to d to the 1. So that is equal to d to the 12 minus 1, which is equal to d to the 11th. And then let's skip down to number 11. Simplify. Assume that the conditions of the quotient of powers property are satisfied. Number 11. So we have here negative 8 x cubed z to the 7th. Negative 8 x cubed z to the 7th. Divided by 2x squared. 2x squared yz. yz. Now remember, you can only combine like terms. So let's just highlight our like terms. We have here our negative 8 and 2. So negative 8 divided by 2 is negative 4. Then we have the what? The x to the 3rd is going to be 3 minus 2, which is 1. So it'd be just x. And then we have the z to the 7th. Z to the 7th. Got to do a y in there, don't we? Get that z, that goes over here. And we got a y. So there's nothing there. And y's on the bottom, so that would put it down there. And we have nothing on top, so you just leave it there on the bottom. And then the z to the 7 minus 1 is going to be z to the 6th. And it'll be on the top. So if you get a negative, it's on the bottom, or there's nothing there. You leave it where it was at originally. So let's go to 12. 12 is h to the 3rd k to the 7th. 12 h to the 3rd k to the 7th divided by h to the 2nd k to the 4th. H to the 2nd k to the 4th. And again, only can combine like terms. So let's look at h. 3 minus 2 is 1, so it's going to be on top. And so we have h. And then we have 7 minus 4 is 3, so k to the 3rd power. And that would be 12. Let's go on to 14. 5/8 squared. 14. 5/8 squared. So you just square the 5, and so that's equal to 5 squared over 8 squared. You know, so that's equal to 5 squared over 8 squared. 5 squared is what, 25? 8 squared is what, 64? And that's how that works. Sometimes you can reduce it. How about 3/4 to the 4th power? Number 15 would be the last one. 3/4 to the 4th power. So equals 3 to the 4th over 4 to the 4th. Alright, so 3 to the 4th power. 3 times 3 is 9 times 3 is 27. 10 times 3 is 81. And 4 to the 4th power. 4 raised to the 4th power is equal to 256. And I believe 81 goes into 256. So let's try it. 256 divided by 81 is, no, we're done. Let's do 9. What, 256, you can reduce the 256 divided by 9. And go out. 256 divided by 3. Yeah. So 81 over 256. You can leave it either way. 3 to the 4th over 4 to the 4th, or 81 over 256. And that'll be all our examples. I think I put down today on page 387, 17 to 25. And on 388, we do 29 to 36 and 45 to 52. So, call a friend, call Hannah Campbell. Now, she's good at it. You know, don't call Mr. Trump. He's busy. Don't call your doctor. He's got plenty of patience. But if all else fails, you can call your teacher. Call your teacher. Call your teacher. Was that really necessary? Oh, I thought it was.